So the question we're going to try to solve today is, what is the largest area of a rectangle that can be inscribed under this graph? So the function in question is e to the negative x squared. Now again, let's restate the problem is largest area for a rectangle under f of x equals to e to the negative x squared. Now let's see what this looks like. If we decide to plot the graph of this thing, and some kind of mathematical software like Wolfram Alpha, and even by just using some logic, we're going to see that because it's e to the negative x squared, it could be also written as 1 over e to the x squared, which makes this similar to 1 over x. Right, because an x squared is kind of also has some kind of resemblance to a parabola and the inverse of an exponential, right? And because we're plugging in any value of x, positive or negative, 1 squared is going to be same as positive x squared. So if you try to do this, you're going to see that this is what kind of what it looks like. Alright, more symmetric. This point right here is 1 at 0. And if you've dealt with exponential functions before, you would know that all of them cross 0, 1. This point right here is 0, 1. Now to the question at hand. What is the largest area for the rectangle under this curve? Now when you hear largest area for something, you might want to think optimization and setting a derivative of something equal to 0. So we're going to say derivative with respect to something, let's say x, of area should be equal to 0. Alright, when we solve that, we're going to find those dimensions. Now, to do that, first we have to find equation for area. Now what would that be? Area of a rectangle is width times height. So what would the width be? Now let's pretend, I'll grab a different color here. Let's say that this is what our rectangle looks like. Alright. And let's pretend that this is the largest one. Alright. Now, because it's symmetric, this guy right here, this x right here, would be same length as this negative x guy. Alright. Now that would be the width. The width would be 2 times x. Now what would be the height of this rectangle? The height of this rectangle would be this guy right here, and this would be the function when you plug in x. Alright, for that specific x, it's called like x naught, just for some kind of more specific value, alright? Go. Now the height of this rectangle would be f of that x naught. Alright, so we're ready for our formula now. Formula for area equals to 2x0 times the function at that value. So that'd be e to the negative x naught squared. Alright. This is width times height. Alright, if we want to expand on this, we're going to see that it's... Actually, no, we don't need to expand. What am I saying? Now let's take the derivative of that with respect to x. So we're going to take a derivative of this guy with respect to x. Alright, so we're going to have to apply a chain rule here. Now for that, we're going to first take the derivative of the first element and leave the second one untouched, so it's going to be 2 and the second one untouched is negative e to the negative x naught squared, plus leave the first one untouched, which is 2x naught, and then take the derivative of the second guy squared, which is going to be negative e to the negative x naught squared, and applying the chain rule here. Oh, I'm sorry, I called this a chain rule. This was a product rule. Alright, applying the chain rule here, we're going to have negative 2x. Alright? Now let's see if we can factor anything out. Yes, we can. So we're going to have 2 e to the negative x naught squared. That's our common factor. We're going to have 1 left here. We're going to have a, sorry, this is also x naught. So we're going to have an x naught times negative 2x naught, which is going to be negative 2x naught squared. Alright? This is our derivative. Now let's set our derivative equal to 0. So we're going to have a 2 e to the negative x naught squared times 1 plus negative 2x naught squared equal to 0. Now when we have two elements multiplied which equal to 0, we can set either one to equal to 0. So moving over here, 2e to the negative x naught squared equal to 0. Well, this is never going to happen because 2 cannot equal to 0. Now e to the power of anything can never equal to 0. So this one does not help us. No, not helping us. So let's try the second one. 1 minus 2x naught squared equals to 0. Let's solve for x. Now this guy's going to be what? 1 equals to 2x naught squared. 1/2 equals to x naught squared. X naught equals to root 2 over 2. And if that doesn't make sense to you, then it's going to be root of 1/2, positive and negative. Now this doesn't really matter because why? Because both positive and negative x are kind of the same thing, and that's not really what we're looking for. What we're looking for is the area, so we're just going to use the positive value and multiply it by what's it called? We're going to multiply it by our e thing. Alright, so moving on to finding the area itself, we're going to say, alright, 2 times x naught times e to the negative x naught squared. Let's plug in our x naught. 2 times root 2 over 2 times, and let's use this form right here, 1 over e to the power of root 2 over 2, the whole quantity squared. Alright, so these 2's cancel, so we're left with a root, positive root 2 on top, and because this guy is squared over here, because it's squared, that means the squared goes away, so we're left with e to the 1/2, which essentially leaves us with square root of 2 over e. Alright, there we go. This is the largest area of a rectangle that can be inscribed in under this curve. So what I'm trying to do here is, I was thinking for the longest time to make a channel on YouTube where I try to solve some math and physics problems, mostly calc and just engineering physics or introductory physics for college, maybe high school students, and I was thinking to get some problems from some of the students that I know that go to college with me, or even from you guys the viewers of this video, and just kind of try to walk through the problems, try to provide some rationale, some tips on how to solve these kind of problems, and just to help you guys through. And I will be welcoming any problems that you guys leave in comments, or send me just like message on YouTube, and I'll be happy to take a look at it and see which ones would provide the most interest to other people and would be most helpful, and I'll be happy to do this on a regular basis. Yeah, I'm kind of into this, so thank you very much guys for watching this. If you guys liked it, share this, bookmark it, subscribe, because I'm planning on publishing more of this stuff. So yeah, thanks for watching and have a good day.